So we're going to find the exact value of all trigonometric functions for the following. When A, we have tangent as being 4/3 and cosine being negative. So I have two pieces of information. One is the value of the tangent, and the other information I have there is that cosine is negative for the same angle. Now let's take a look first at the tangent. Tangent, by definition, is y/x. Based on the point on the terminal side is y/x. Now what it's telling me is that the information above says that I could take the value of y to be 4 and the value of x to be 3, but this is not the only case where I get the result 4/3. I could also think of -4 over -3, because that also results in a tangent being positive 4/3. Okay, so you have to remember that being a result positive comes from two options. You either have both numbers positive or both numbers negative, and that's how you get the 4/3 for the tangent. I also have the other information that cosine is negative. Now, what does it mean, cosine being negative? Cosine, by definition, is x/r. R is always positive. And if cosine is negative, it means that the x value has to be negative. So I know from the second piece of information that x is negative. Now, if x is negative, the only way that can work is in this fraction here, when both x and y are negative. So my take is that I think about the tangent, so there are two options, two pair of values, y = 4, x = 3, or y = -4 and x -3. Because the cosine is negative, it tells me that x has to be negative. So the only option that really works is this option. So conclusion here so far is that x has to be taken to be -3 and y has to be taken as -4. Okay, and the division there still give me tangent positive 4/3. Now, why do I need this? First, I need to compute all trigonometric functions. So I need both x, y, and also r. And r, we can compute r by using Pythagorean, theorem, which tells me that r is going to be the square root of x squared plus y squared. So if you plug in the numbers there that I figured out, which is -3 for x and -4 for y, and do the computation, we have square root of 9 plus 16, so that's 25. So square root of 25. So we have that r for us in this problem is 5. Okay, so now I have everything that I need, x, y, and r. So now I'm ready actually to evaluate all trigonometric functions. So let's start. Okay, so we have, let's start with sine first. So sine of the angle is defined as y/r. Now we know that y is -4, r is +5. So basically it's -4/5. So sine is negative. Cosine, which is x/r, the x value is -3. So we take -3 divided by 5. So this is -3/5. Next, let's do tangent. Tangent is y/x. We already have that from the beginning. We know that's 4/3. So this one is just writing there, but it's already basically given the beginning. And now let's do cosecant, which is the reciprocal of sine, which means r/y. So we have 5/-4. So the result is -5/4. Secant is r/x. Remember the reciprocal cosine. So we have 5/-3. So I can write this simply as -5/3. Finally, the last one, which is cotangent. we have x over y. So we have negative 3 over negative 4, which is positive 3 over 4. Or you just flip the tangent that you had in the beginning by a trigonometric identity that we saw before, and you get the same value, which is 3 over 4. Okay, so this time for part B, we have a point on the terminal side of an angle. The point is 3, negative 3. So what I need to do, again, to find all trigonometric functions from the point, I have both x and y. So from this point right here, we have that x is 3 and y is negative 3. So what we needed to do is to compute r from that. Now, you can do a sketch, not necessarily, if you understand, but notice that from the point you can at least position the terminal side of the angle. We don't know what the angle is, right? It could be positive or negative, but I know the position of the terminal side. I just want to quickly point that out. So you have x equals 3, y negative 3. So together, this gives me the location for this point. So I know the terminal side of the angle, whatever the angle is, which again, I don't know if it's positive or negative, how many rotations going around before stopping. I don't know any of this, but I do know where is the position of the terminal side, which is given by the point. So this is the point, 3, negative 3. So r, again, by Pythagorean theorem, is the square root of x squared plus y squared. Plug in the numbers. So we have that that is going to be 3 squared plus negative 3 squared. So we have square root of 9 plus 9, which is 18. We can simplify square root of 18 because that is 9 times 2, right? So if you separate the multiplication there, we have that that's 3 square root of 2. So we have r. Now with that r, I can compute all trigonometric functions again. I want to write sine first, so sine, which is y over r. Y by definition coming from the point, that is negative 3. So we have negative 3 over r, which is 3 square root of 2. Notice that I can reduce the fraction, right? Both 3's cancel each other. So I could simply write this as negative 1 over square root of 2. Sometimes the problem asks you to also simplify the square root. So if you multiply top and bottom by square root of 2, so if you multiply top and bottom by square root of 2, you get that simplification as well. So the result is going to be negative square root of 2 over 2. Again, I'm simplifying all the way to the end, but again, depends what the problem is asking from you. Sometimes there's no need for that simplification, just be aware. All right, so now let's do cosine. Cosine is x over r. X from the point is 3. So we have 3 over r, which is 3 square root of 2. Again, you can simplify that, or can simplify even further, which is square root of 2 over 2. So you can leave it like that, or you simplify a little bit further and simplify the square root as well. So now let's do tangent. So tangent, which is y over x. By the way, for the tangent here, I didn't need to compute the r. I could right away from the beginning, from the point, to do that computation. But the result here is negative 3 over 3, which is negative 1. Now, if you flip, right, each of these trigonometric functions, you're going to get the other 3 trigonometric functions. This is a work I will leave for you, so you have to complete this, okay? So complete this problem on your own.